Germain Morton's full-body bike chassis mobility vehicle, a revolutionary advancement in electrodynamic transportation design.
Germain Morton, an inventor known for pioneering numerous groundbreaking innovations in modern engineering and mobility, has introduced yet another visionary creation, the full-body bike chassis mobility vehicle. This invention revolutionizes conventional bicycle architecture by merging traditional mechanical principles with cutting-edge electrodynamic systems, including electromagnetic propulsion, capacitive charge interfaces, and novel structural configurations. Morton's innovation extends beyond the simple purpose of transport. It redefines how kinetic energy, structural integrity, and electromobility converge.
Structural foundation. C-frame transductor chassis design. At the heart of Morton's invention is a stacked sheet metal structure composed of conductive cathode-charged aluminum, iron, and copper layers. These materials are repeatedly configured in a C-frame transductor pattern, providing the chassis with both mechanical resilience and a functionally integrated circuit network. The C-frame acts as both a load-bearing frame and an active transducing component, capable of converting electrical signals into mechanical propulsion and feedback regulation. This dual-purpose design is a cornerstone of Morton's innovation, drastically improving the energy efficiency and responsiveness of the mobility vehicle.
Electromagnetic chassis and commutator configuration. Morton's full-body bike chassis is not merely a passive framework, but an active full-body electromagnetic chassis system, embedded with a commutator structure. This layout allows alternating currents, AC, particularly electrostatic displacement transmission, EDT, or wireless power transfer, WPT currents, to flow through embedded emitter nodes across the chassis. These nodes are responsible for emitting controlled Gauss force fields, which act on the magnetic wheel armatures. The generated electromagnetic flux interacts dynamically with the rotating wheel mechanisms, effectively reducing friction and enhancing rotational torque.
Wheel and rotor engineering, PMSM and airless tire integration. Each wheel assembly in Morton's design is a microcosm of electromechanical ingenuity. The wheel's core is centered around a permanent magnet synchronous motor, PMSM, rotor housed within a ball-bearing bracket and sprocket mechanism, allowing for minimal resistance rotational motion. The wheel's interface includes modulated AC-DC voltage capacitor disc interface, controlling current flow and charge accumulation, twin-bearing electrocapacitive interface for dynamic energy distribution and stability, permanent electric materials used in the rotor continuously generate electrostatic fields without external power, enabling sustained electromagnetic support.
Additionally, airless tires enhance durability, puncture resistance, and structural simplicity while maintaining optimal traction and road contact. Electrostatic emission and potentiometric range systems. One of the more futuristic aspects of the design is the electrostatic emitter mechanism incorporated within both the chassis and the wheel structures. These emitters create finely tuned electric fields that interact with the surrounding environment or road surface to enhance vehicle control, energy regeneration, or friction modulation. The system also includes potentiometric range design parameters, enabling feedback-driven control over energy distribution, torque application, and user-driven modulation of riding dynamics. This potentially allows a chassis to adapt in real time to road conditions, rider weight, and directional forces.
A paradigm of intelligent mobility. Germain Morton's full-body bike chassis mobility vehicle is more than an electrically assisted cycle. It is an intelligent mobile system, optimized for urban and off-road transportation, personal mobility, and next-generation transportation frameworks. By integrating commutator-based electromagnetic drive, capacitive electrostatic interfaces, and lightweight conductive structural stacking, Morton has created a vehicle that represents a leap forward in sustainable transport, rider adaptability, and autonomous design potential. Conclusion. Germain Morton's invention embodies the convergence of materials science, electrodynamics, and mechanical innovation in a unified, user-focused transportation device. Its scalable architecture, based on modular stacked elements and advanced electromagnetic control, offers unprecedented performance and adaptability. This mobility structure, versatile, efficient, and designed for the future, demonstrates Morton's commitment to reshaping the landscape of global mobility with technologies that defy traditional limitations and pave the way for electric autonomy on two wheels.